All right, so this is the May 2023 paper. So the first question is the FIFO question, or the named pipe question, basically. So we have already discussed like what is FIFO in one of the previous sessions. So I'll go over it briefly again. So basically, when you're running a command this way, where you have the round brackets and you run a command inside, and you have less than angle bracket to the left of it. So when we basically run something, so for example, if I run the ls or my home directory, if I directly run this, then we obviously get the output. If I run this inside this round bracket with a dollar, so the this command is run and its output is returned, and that we can store, let's say, like in a variable, or we can also give it to any other command. So for example, I can give it to echo. So whatever is the output of this, that is given as an argument to echo. So echo will also print those same way. So instead of the dollar, we can also use the less than angle bracket symbol. So what this will do is, this will also run this command in a subshell, just like the previous one. But instead of giving back the output, like the standard output directly, what this will do is, this will store it in a temporary named pipe or a temporary file in your file system. And it will just give you back the path of that temporary file. So you can see it will only give you back the path where this file will be stored. So /dev/fd/63. This will just be a random number. And if you cat that file, which is given back, that path of that file, there you will get the output that is generated by this command. So this is basically a way of running a command and storing its output in a file. So this is actually not stored in a file. So this will not be stored in your file system, but this is something called a named pipe. So we already went over how named pipe works. So you can refer to that video. So this will basically store the output in the memory itself. So it will ask the command to give the output line by line, and whoever is reading that file will also read the output line by line. So here we are using the cat command to read the file then. So earlier we used the echo command to just print the path of the file. So now we are using the cat command to basically print the what is there in that file. So we can, because this is just like a file, we can also use it with other commands. So for example, I can use it with grep. So in grep, the syntax is first is a pattern and then is a file. So the pattern can be anything. So for example, if I give the pattern as starts with do, so then you can see we can basically grep on the file which is the output of this command. So on the output of this, obviously we have two folders, docs and down. So we can also do grep on this. Similarly, we can do things like diff, etc. So I can do diff between two files. So not real files, but temporary files. So here basically I am running the same command two times. So you can see obviously the difference is nothing. So there is no difference in the output of these two commands. So this will basically execute both these commands and store them in the temporary files, and then give the temporary file paths to diff. So earlier we saw we only got dev fd63, but obviously if you're running it multiple times, we will get multiple paths. So as you can see, this is 63 and this is 62. So we can also, instead of doing ls, I can, let's say, do something like date. So I can do date %s%n, and here also I can do date plus %s%n. This is basically the seconds till now and the nanoseconds till now. So even though we are running this at the same time, obviously there will be some nanoseconds difference between the running. That's why the output of this command and the output of this command is not exactly the same. You can see the first, everything will be the same, but near the end, you can see the last three digits are different. So because they run a few nanoseconds after each other. So basically the output of this and the output of this are stored in two named pipes, and we can use diff to get the difference of these two. So that is,
Excuse me, sir.
yeah.
Sir, what does this 1C1 represent?
So 1C1 basically means which line number there is some difference. So C means there is a change. So there are three types of differences. One is in like between the two files, one file has one extra line. So that will be written as added. So for example, let me add file 1, and here I have hello, how are you? And here I have file 2 where I just have hello. So if you can see, if I do diff file 1 and file 2, so file 1 and file 2, the first line is exactly the same. The second line, like in file 1, we have a second line, whereas in file 2, we don't have any second line. So here you can see we are telling 2D1. So in the left number is the left file's line number, and the right number is the right file's line number. So it's telling in file 1, line 2 is there, which is deleted. So it is not there in the file 2. So after line 1, there is nothing there in file 2. And what is that line which is deleted? That is how are you. Similarly, if I reverse the order of checking, so if I do file 2, file 1, then you can see it's telling in the first line of file 2. So after the first line of file 2, there is an addition of a line which is present in the second line of file 1. So, and that line is how are you. And similarly, if we have like this, where like the lines are same, but there is some difference in the line itself. So the content of the line itself is changed. So then we have C. So it's telling the first line and the first line of the two files have a change. So the lines are not same. So they are this. So this is the file 1 and this is the file 2.
Got it, sir.
Yeah. So another thing, can you notice from this, what is the order of execution of these commands? So date,
Sir,
yeah, go ahead.
I think the second one is executed first, then the
Yes,
first one.
yes, exactly. Because this is like 80 nanoseconds, this is 140 nanoseconds. So first this is executed and then this is executed. You can also see that when we are echoing these, so even the like allocation, like the numeric allocation of these paths are also like this one is 62 and this one is 63. Right? So the right side is done first and then the left. So what if we have it 3 times? So you can also try that out and see. So if we run it again, sorry. Okay, so we obviously cannot run diff 3 times with 3 files, but we can obviously run echo. So you can see it is basically in the reverse order. So this is 61, then 62, then 63. Or we can also use cat to see the content of the files. So you can see this is 494. This is 434. This is 444. Okay, so interesting, right? So second one ran first, then the first one, and then the last one. So actually what happens is they are not run one after the other, but they are run parallelly. So all of these, so basically bash takes a few time to first like create these files. So these files are created in this order. So first the last one, then the second last one, then the third last one. And all the commands are executed asynchronously. So this, even if it takes like 10 seconds and this takes 10 seconds and this takes 10 seconds, the entire command will take a total of 10 seconds and not 30 seconds. So they are run parallelly. So you can see, like, because this is a very like fast command, so sometimes this will finish first, sometimes this will finish first. So this is basically the second one finished first and we got 434. Then this one finished first, we got 444, and then this one finished, so we got 494. Right. So, but with the like order of creation of the files, we can see that this is last one, then second last, then third last. So in the question, we basically explained what is this process substitution with the FIFO files, FIFO, or first in, first out. So then we are given a few examples. So if we simply run the seq25 command, then we will get the lines 2, 3, 4, 5. But if we basically run two, one is seq13 and one is seq25, and we get the difference between their outputs, then obviously this is 1, 2, 3, and this is 2, 3, 4, 5. So this one has 1, whereas this one has 4 and 5. So this is the output. So then the question is, what does the command echo left angle bracket sec10 output represent? So we just now saw that when we are simply echoing what is returned by this, so this will simply return the path of the named pipe where the output will be stored. So this will not print out the output of this command. So that's why the first option is incorrect. So this will not print out the standard output from the command sec10. This answer will be correct if this was cat. So if we were catting out that file, then this answer would have been correct. But here, because we are simply printing what we are getting, so here we are simply printing the path of the file, right? Like this. So when we are just printing the path, so we are just we don't get like, even if I am running date or sec or whatever, whatever command I'm running, I will always get just a path of a file. So if I run just once, I'll get only one path. So that's why this is just one file whose path we are getting.
We already discussed this question, right?
Yeah. This was there in the previous paper also. So
Yes.
yeah, that's why I'm not going into the depths of what is FO, like FIFO, and how to
That is
create.
temporary file, right?
Yeah. So we also discussed how to make these, right, and how to do it
Ah,
manually.
yes, yes.
Right. So this is the first question. I think all these questions are
I think
similar.
this paper is discussed already.
Yeah.
Alice question is also there.
Let us see if all the
Two
questions.
Alice questions. Same
Yeah.
paper, two Alice questions.
This is the cron was also discussed.
Yes. Yes. This.
Okay. This.
Yes,
Okay. I think
this.
the entire paper is
Same
same.
for forenoon and afternoon, I think.
No. This is different term itself, or maybe I downloaded by mistake. One second. Let me see. So we have done the 23 Jan AN. So here we had this FIFO and Alice. Then we did the 23 Jan FN. There it was a different paper. We had all this tabs and all. And we also had this common question of cron. And then 23 May, this one also has the same questions, I think. Or maybe it is the same PDF that is provided. Yeah, May. Yeah, I think the PDF given is wrong. So let us do the
Yes.
FN. Maybe that is correct. Okay, yeah, we are getting different questions here. Okay,
Yes.
so yeah, sorry for the like same questions. Okay, so let's discuss this paper, and I'll try to get the correct May paper, and we'll discuss that tomorrow, and I'll upload that video. Okay, so in this question, we are asking select the correct statement from the options for the following command: cat. So what happens when you are running cat without any file to cat? So by default, cat will print whatever file you're giving to it. Like for example, here if I do cat file1, it will print that. Similarly, if I do cat file2, it will print that. But what happens when we like run cat without any file?
It stops to take the input.
Yeah, it will take it from the standard in, right? So it
Yeah.
will take input from standard in. And if I have not redirected anything, then this will basically take from my keyboard itself. So whatever I type, it will basically print that itself. So that is basically how cat works without a file. So here we are telling cat $cat. So we are basically running, so let me clear the screen. So we're basically running this command. So the first cat will run uh, and it will wait for input from the terminal. So it will read the standard in, and whatever you're typing, it will basically again print that back. And that output is then given to another cat. Right. So if this was simply an echo, then whatever we typed will be printed back. So if I do, let's say, hello, how are you? So as you can see, it is not printed back right now because this is running inside this subshell. And only when I finish giving the input, the entire thing will be given back to the echo, and then the echo will print it. So now if I press Control D to stop giving the input, now you can see the entire thing that we wrote, hello, how are you? That is then given back to echo, and echo then prints everything, hello, how are you? So I think maybe if we use E, we may get the line breaks correctly. Okay, so it will basically be in the same line itself. So now instead of echo, what happens if I give cat here? So it will still ask me for input, but after giving the input and after I press Control D, what will it happen? So instead of echo, we are using cat. So what will cat try to do if it gets
Cat will
basically?
try to open a file. Cat will try
Yes.
to open a file with an input.
Yes, exactly. So let me also show the like files we have here. And now if I, sorry. So now if I run this cat, so here if I, let's say, type file1 and I press enter and I then basically press Control D to stop giving the input, then cat will basically print what is inside file1. Similarly, if I give file2 and Control D, so cat will print what is there in file2. And if I write something which is not name of a file in my current directory, then it will basically give you an error that no such file or directory. So you can see that here the options are: the command opens the file named cat, which is obviously not correct. So it would have been correct if we had written cat. So then this is the command and this is the name of the file. So then the first option would be correct, but it is not the case. So then the next option is: the command takes standard input and prints the received standard input. So this would have been correct if it was echo cat, as we saw just a few minutes before. But this is also not true because we are doing cat. So the third option is: the command prints the content of the file names obtained from the standard input. So this is basically what is happening. So if I do cat and if I do file1 and file2 and I do Control D, so you can see it will print all the files received from the standard input. So file1 it will print and file2 it will print. And if I give any wrong path, then it will not print that. Right, so that is why the third option is correct. And the fourth option is: the command throws an error since no argument is given to the command cat in the inner cat. So obviously that is not true. We can run cat even without any argument, and it will take from the standard input. So that's why for this question, the third option is the correct option.
Sir, what is Control D here?
Control D means the end of input. So cat will stop reading the standard input when I press Control D.
Control C?
A Control C is an interrupt signal, so that means you want to stop the execution of the current foreground task, so that you can use even if the program is not taking standard input. So let's say the program is actually in a loop or something, or it is doing some process and it's busy. If you do Control C, it will stop that or interrupt that process. But Control D just means I am done giving the input. So if the command is reading input and you're writing multiple lines of input, after you done with the input, you can press Control D to basically signify the end of line input.
Okay,
so it will stop reading the input.
Okay.
So, what is the difference between less and more commands?
So they're similar. So they serve the same purpose. So more was invented before. So more is basically the older command.
Page by page, right?
Yeah,
It gives
both
the-
will paginate the output. So for example, if I have this etc password file, right? So I have this /etc/password file. So a lot of lines are there. So if I do more and then etc password, so it will basically only print one page, and then I can press the down arrow key and I can go next line by line, and I can also go up. So it depends. If I think the more may not support going up. So okay, yeah, I have actual more. So more is basically the older one, and it does not have much features. It is very simple. Whereas less is the newer command, which so newer compared to more, but it is also very old. But it is newer compared to more, and it has more features than more. So the name is a bit confusing. So it may feel like more is more than less, but actually less is more than more.
Yes.
So both serve the same purpose. So both will paginate the output. So you can give it a file like this, or you can give it standard input also. So I can run cat etc password to get everything on my screen and type that to the less command. So that will also work. So hopefully this is clear.
Yeah.
Okay, so okay, in this paper also we have this. So I will not explain this again.
வரேங்க எங்க சிவன் கோயிலுக்கு போய் விளக்கு போயிடலாமா?
Yeah.
முருகருக்கு விளக்கு போடணும் ப்ளீஸ்.
Shanmugam ma'am, you are speaking, you're not in mute.
ஒண்ணுமா இப்படி தானமா போறோம். ஜஸ்வந்த் வேணா சைக்கிள் எடுத்துக்க சொல்லுங்க.
I think I should.
சரி நான் 3 பேர் மட்டும் போயிட்டு வரலாமா?
Okay. Okay. So let's see the next question. So I skipped this question because we already discussed this. So in this question, the question is which of the option is correct output of the following command? So here we have a multi-line string that we are echoing. So echo alphabet, alpha, beta, gamma, omega, iota, nu. And this total output. So if you are giving multi-line string to echo, it will also print multi-line only. So for example, if I do echo, hello, how are you, etc., etc. So this will also print in multi-line. That will not come in the same line. So this multi-line input, basically we are then piping into awk. So in awk, what we are doing, we are first searching for lines that match this pattern. So starts with alpha. So which lines here match this pattern, starts with alpha? Like the line should start with alpha.
First and second.
Yeah, the first and the second both match, right? Because alphabet also starts with alpha. And yeah, and the second, like ending part of the range is given as the regex starts with omega. So this only matches once in this third last line. So, and in the range of the alpha to omega, we are basically printing those lines. So then the confusion arises whether this will print the first line or not. So it will obviously print alpha, beta, gamma, and omega, but will it print alphabet also or not? So let us try that out. So if I have alphabet, and then alpha, beta, gamma, omega, and then iota and nu. So if I then pass this into awk, where we are asking it to match any line that starts with alpha, which matches the first and the second line, and till the line that starts with omega. And for all those lines, we will print each line in that range. So if we do this, then you can see the first match itself is alphabet. So it will match there itself, and till omega is basically till here. So it will print not just these, but also the alphabet. So alphabet, alpha, beta, gamma, omega will be printed by the awk command. Then we are passing that output to sed. And what we're doing is we are removing the first line and the last line. So 1D means the first line should be dropped, and then semicolon means another command, and dollar is the last line. So $D means the last line is dropped. So basically alphabet and omega will be dropped. So the output then will be alpha, beta, gamma. So if I then pass this to sed 1D, $D, you can see the output is then alpha, beta, gamma. So then we have to choose which option is correct. So the first option has all the things, so that is obviously not correct. In the second option, we have alphabet, alpha, beta, gamma, and not omega. So this is not correct. In this, we have omega, iota, nu. This is also not correct. So this last one is the correct option, which is alpha, beta, gamma. So here, if we assume that this will, like the awk itself will print alpha, beta, gamma, omega, then our output will be wrong. So we will think the output is beta, gamma. But fortunately, beta, gamma is not one of the given options. So if that was also a given option, then this would have been more confusing. But in the given 4 options, obviously the fourth one is only the plausible option. The others one are implausible. So this is how we solve this question. Just let me know if this one is clear.
Yeah, it's clear.
Yes.
Okay.
So what would have happened if there was beta and gamma? I mean, you said something.
Can you repeat that?
You said something about if there was an option having only beta and gamma. When would
then we may be confused that this alpha will match this alpha, right? So although we know that this will match like the first one which is matching, so alphabet also matches this, so it's printing alphabet till omega and not alpha till omega. But if we had the misconception that it is only going to print alpha till omega, then we might think that the final output would be beta gamma. So in that case, we will be confused whether beta gamma is the correct option or alpha beta gamma is the correct option.
Okay.
But fortunately, that option is not there.
What does $D indicate in the set command?
So dollar means the last line. So similarly, like 1D means drop the first line, $D means drop the last line. So
Okay,
we can
$D.
also,
Okay, D means drop.
yeah. So we can also, like, if we do $P, then it will print that last line. So we can give any command and the line. So this is just the line addressing. So dollar means the last line. Right, so let's see the next question. So in a text file named numbers.txt, multiple lines contain numbers. You want to delete all lines that have numbers greater than 100. Which set command would you use? Hence, by default, set uses the BRE. So we have to basically select the options in BRE. So we have a file which is numbers.txt, and it has multiple lines contains numbers. So let me create a file like that. So numbers.txt. So I have a few numbers here and maybe a few text also. So I'm not sure if they are having text there also, and a few numbers which is greater than 100. So then the question is, you have to select a sed script which will delete all lines that have numbers greater than 100. So I think this might be greater than or equal to 100. Once then it will be, like, we can do it in sed. So how can we basically match all those lines that are greater than or equal to 100? So like, what property of a number is satisfied only when that number is greater than or equal to 100?
So 3 digits.
Three digits.
Yeah, exactly. So if we have 0 to 9 and that is present 3 times, I don't have to give 3 comma, because 3 itself will also match the substring of like more than 3 digits itself. But if, as this is BRE, we have to escape these curly brackets. So now if I run this sed script on numbers, so I have to also tell what to do on this. So if this regex is found, then drop that line. So if I do this, then you can see all the lines that have 3 digits are dropped. And even if we have, let's say, a line with 4 digits, that will also be dropped. So only numbers less than 100 and text are preserved. So I think that is how this option will be doing. Yeah, so you can see the first option, which is the correct option, does exactly that. So we are matching regex, which is 0 to 9, 3 or more. So we can do 3 or more, or we can just do 3, because even if we are not matching all the digits, if we are matching 3 digits, we will still match 3 digits when there are more than 3 digits present. So a substring will still be matched. So this is also correct, and this is also correct. And we basically drop those lines where this regex is matched.
Excuse me, sir.
Yeah.
Sir, I had a doubt in this question. Like we have 0 to 9 digits 3 times, but if the first digit is 0 by chance, then the number will become less than 100.
Yeah. So then basically we have to assume that the numbers are well formatted, right? So there is no like leading zeros in the numbers. But yeah, if we have something like that, so this is just text matching, right? So it has no way of actually parsing numbers. So even if we have 0, 1, 2, it will drop 0, 1, 2 also, because it is just matching 3 digits. So 0, 1, 2 is also 3 digits. So this will also basically drop this, even though this is not actually a number greater than or equal to 100. So a few things you can do, like you can say that the first digit has to be 1 to 9 itself. So what you can do is you can do 1 to 9 and then 0 to 9 present 2 times. So this is, I think, a little bit better. So here, if we have 0, 1, 2, this will not be dropped. If we have 0, 0, 2, then that also will not be dropped, because, as you said, only if when the first character, like the first character is 1 to 9, we are dropping them. So Yeah, in that case, this would be a more better regex, right? So that the first digit we are not matching as a 0. But in this question, I think they're assuming that all numbers are not having any leading zeros. Also, I think this is like misprinted. So this should be a number greater than or equal to 0, because even if, sorry, greater than or equal to 100. Because even if we have 100 here, so that will also be dropped, right? Because that is also 3 digits. So this is the correct option. Let us see if there are any other options. Yeah, so the second and the third option basically uses extended regex without using the minus capital E flag. So we can use extended regex, but we have to use the minus capital E. So here it is not using that, and it has also not escaped the curly braces. That's why the second and third options are incorrect. And
So
in
if
the
you use extended regex, can we skip the backslashes for the curly braces?
yes, so you can see it will give the same output.
Okay, thank you.
Yeah. So the fourth option basically is also like correctly escaped, but here we are telling 2 or more, which is obviously not correct. So greater than equal to 100 means 3 or more digits. So this will also match 2-digit numbers. So this is not correct. So only the first option is correct here.
So one query here. 0 to
Yeah.
9, 3 would match exactly 3. Only if we have a comma, it would have been 3 or more, right?
No, so it will match only 3 digits in that. But even if I have, let's say, something like this, so you can see I'm running 2, right? And not 2 comma. Or if I ran the previous simplified one also. So even if I have not given a comma, it is still dropping this one, right? 6372. So it is not matching the entire number, but it is matching a substring in that number. So it is matching
Okay.
637. So
it also takes a substring. Yes.
yeah. So it is not matching the entire thing, but it is basically able to match 3 digits if there is 3 or more consecutive digits. So that will also automatically.
Okay, thank you.
Yeah. Okay, so let's move on. So in this question, we are asked select the correct statement from the options for the following set. So we have to basically explain what this is doing. So let me try to zoom it maybe, yeah, so that we can see the question and try to solve by ourselves first. So here the question is select the correct statement of basically what it does. So we have said 5 tilde 5. So what does this 5 tilde 5 mean in said?
Starting from the fifth line, every fifth line we will apply the regex given.
Yes, exactly. Right. So it will only run on the 5th line, 10th line, etc. So let me create a file, sample.txt. I don't know what they're trying to match. So basically, every 5th line, we are doing a substitution here, right? So this curly braces is basically a way of putting things, multiple compound statements in one. So even though here we only have one statement, so this curly braces is basically not required. But even if we have it, it is basically not doing any difference. So here what we are substituting is we are searching for a word boundary and then a group. So because this is BRE, we have to escape the group. And this is one alphabet character, one lowercase alphabet character, followed by the uppercase of that character. So basically, if a character is present once and then present in the uppercase character, my bad. What we are doing is we are matching the word boundary and the one character, which is a group. Then we are substituting that with the uppercase version of that group, right? So we are matching word boundary and one character after the word boundary that we have grouped as the group 1, and we are replacing that search with the uppercase version of that. So basically whatever character we have, it will be uppercased, and this we are doing globally. So all the starting letters of each words will be capitalized. So for example, if I simply add a few lorem, so let me just add a few lorem here. I've added a few lines in this. So you can see if I cat out this file, so this has a lot of basically words, and each word is lowercase, like the first letter of each word is lowercase except the first word and some other words. But what this script will try to do is make every word in every fifth line. So the fifth line, then the 10th line, etc. So it will take the first letter of every word and make it into the capital letter. So let us try to run this. So we will do sed and then this 5 tilde 5. So for every fifth line from line 5, we substitute so we are searching for the word boundary so that we only get the first letter of each word. And then we have the group which has a lowercase word, and we substitute that with the \u, which will not print anything by itself but make whatever I put after it uppercase. So here we're just putting that group, and we do it for all the words in that line. So if I do it on sample.txt, so although we're not getting the line number, but you can see the fifth line is this one. So here you can see where did it go? Yeah. So each word in that fifth line, so every word, the first letter of every word has been capitalized. So although in the original on the top you can see only a few words are capitalized, in here all the words in that fifth line are capitalized. So that is what this script is doing. For every fifth line from the line 5, it will capitalize the first letter of each word. So let us see the option. So the first option is all characters in every fifth line of that text are capitalized. So this is not true. So this is not all characters because we have the word boundary here. So a character after the word or a lowercase letter after the word boundary. So this can only be the first letter of a word. Then we have starting character of every fifth line is capitalized. So this is not just the starting character, although this would have been true if we did not have the G here. Right. So, but we are not doing it just for one occurrence. We are doing it for all the words in that line. So the starting character is not true, and starting character of each word is capitalized. So this is also not true because this is done for every fifth line. So the last option is correct. So starting character of each word of every fifth line is capitalized. So that's how we solve this question. Just let me know if this one is clear.
The /b won't affect the first word of the line because that won't have a word boundary. Right? So this won't.
No, that will also have a word boundary. So for example, if I do here hello, and then I do sed substitute word boundary and then A to Z with the uppercase of that. So here you can see even this one has a word boundary. So start of the line is also a word boundary. Any non-alphanumeric character, like the presence of that is also a word boundary. Like that character itself is not matched as the word boundary, but the presence of that will mark this as a word boundary. And also like start and end of lines are also word boundaries.
Okay.
Yeah. So this one is clear how this works. So here we don't need the curly braces. Even if we add them, we will still get the same output. So also run with that. So here also you can see which is the fifth line. Yeah, so still the fifth line, every word is capitalized. And hopefully this one is clean. So let's move on to the yeah.
In this question, if we wanted to replace, let's say, the space before the like the first letter,
Yeah.
also here we're using word boundary to identify it. So in that case, what would we do if you wanted to replace the space as well?
So if you want to, let's say, replace the space, then what you can do is you can do like space and then a word boundary. If you only want like, let's say, the space after, like before a word. If not, if you want to replace all the space, you can simply do space and replace that with something. So this will work. So all these spaces will become dash. But if let's say there are multiple spaces and you want to only replace the space that is before a word, you can do space word boundary. So it will only replace all the spaces before a starting of a word with whatever you replace it.
Thanks.
So let's move on. Okay, so this is again a cron question. So I will not explain it too much because we have already done cron questions in the last 2 sessions. So this is basically the minute, hour, and then the day of the month. So on every 4th of every month, like on 4th of every month at 4:00 a.m., this command is run. So it is asking at what time it is running. So 4th of each month at 4:00 a.m. So the meaning of each field is also given here: minute, hour, day of the month. And whenever we have stars, that will be a any value will satisfy that. So the only constraints here is 044. So minute 0, hour 4, and day of month is 4. So then we will be running this script. Right. So this is an extended matching question. So we have to basically choose the incorrect answer to the question. So basically we have a list of questions and answers, and we have to see which question is not, like which answer is not the answer to that question. The first question is, what is a process in Linux? Answer: in Linux, a process is an instance of running program. It represents the execution of a program and consists of program code, data. And so this is correct. So next is, how can you view the list of running processes in Linux? You can use the ps command to view the list of running processes. This is also correct. Third is, what is the difference between a FG and a BG process? So a FG process is a process that runs in FG and interacts directly with the user through the terminal. It receives input from the user and displays output on the terminal. On the other hand, BG process runs in BG without user interaction and does not occupy the terminal. So this is also correct. And finally, how can you terminate a process running in Linux? You can terminate a process using the kill command. Kill command sends a signal to the process requesting it to terminate. The most common used signal is the sig term or signal 15, which gracefully terminates the process. So all the questions and answers are correct. So here the option is none of these. So none of these are incorrect. And hopefully this one is clear enough. Okay, so let's move on. All right, so here this is again like the similar question. So earlier we saw a question of matching the GST in of a company using regex. So GST in basically has PAN inside itself. So here we have a simpler question where we have to just match the PAN card number with a regex. So we have to basically select which regex matches PAN card. So the format of PAN is given to us. It is like this: ABCD, ABCTY, 1, 2, 3, 4, D. So everything in capital. So the first 3 letters can be any letter from A to ZZZ. So obviously to match that, so let me create a file which has PAN. So this is ABC TY 1, 2, 3, 4, D. So to match a PAN, the first 3 letters can be any uppercase letter. So it can be A to Z present 3 times. So let me just use extended regex. And after that, we have the 4th letter, which can only be a few values, like it can be T, F, H, P, C, etc. So we will simply put the possible values P, F, H, P, C. And then the 5th character, it will represent the last letter of the PAN holder's last name. So a person's last name can start with any character. So there is also again no basically limitations on this. So this will again be A to Z. Obviously, it cannot be like a letter. I mean, it cannot be a number. It has to be a letter. And then we have 1, 2, 3, 4, D. So the subsequent 4 characters are sequential digits from 0001 to 9999. So this again can be like basically 0 to 9 present 4 times. So 4 digits consecutively. And then finally, the 10th character is an alphabetic check digit, which also ranges from A to Z. So again, we have a A to Z. So if I then run this regex on the pan.txt, so you can see this successfully matches this PAN number. So this will basically be how we match a PAN number. So that is also the solution. So you can see A to Z present 3 times. So here they have used BRE. So in the question it's told assume a BRE. So we have to escape the curly braces. So A to Z 3 times, then TFHPIC. I think I missed the I. Yeah. Okay. Okay. I was not mentioned here itself. Okay. So there might be some small mistake here, but then you get the idea of this. So TFHPC or TFHPIC, and then A to Z, then 0 to 9 present 4 times, then again A to Z. So this is how we match this. So in the first option, we are also matching lowercase, whereas this clearly says it has to be all capital. So that's why the first option is incorrect. And the third option also is same as the first option. So alpha matches both lowercase and uppercase. So that's why this is not correct. And the fourth option is correct because upper is same as A to Z. So we are matching only uppercase letters. So hopefully this one is clear how this works. So let's move on to the next one. Okay, so in this, select the command that retrieves the first 10 lines of all the files that only ends with .md in the current working directory and its subfolders. So basically what we have to do is, 1 second. So let's say we are in a current working directory, and in there we have some file a.txt, and then we have b.txt. So we don't care about txt files. And let's say we have a file c.md. So we will print the first 10 lines of c.md. Similarly, let's say I have a folder here, D, and inside that folder I have, let's say, e.md. So I will also print the first 10 lines of e.md as well. Right. So obviously we have to use find here, right? Because we want to recurse through all the files in the current directory and subdirectories of the current directory. So we will start with the find command. So let me also create a directory like that. So let me, let's say, have a few files and maybe few MD files. And let me create a few folders. This are a few folders, and then inside each of those, I will have a few MD files as well. So what comes after them? Yeah. So let me just have it as a file.md. So inside each folder, I'll have file.md. So now you can see we have basically like this. So we have hij.mds here, and then file.mds inside these folders. So let me also add a few lines in them. So let me just add the output of sec 100 in all of them. h.md, i.md, and j.md. And maybe let's make it different so that it's easier to understand also. So j is 100 to 200. And similarly, let's say 50 to 150 on k/file, and then 20 to 150 on l/file, and then 30 to 150 on m/file. Okay, so now we have the same structure, but then some contents in those files as well. And what we want to do is we want to print the first 10 lines of all the files with .md extension in all the files and subdirectory. So first thing we will use is the find command to basically list out all the files in the current directory. So if I just run find, it will give you path of all the files. I can also reduce the number of outputs. So let's say I don't want the folders itself, so I can give type as F. So I only get the files and not the folders, like L, M, K. Those are not printed. Only the files inside those are printed. And I can also get only those files that have a .md. So I can give star.md. So this is not regex, this is globbing. So I don't need dot star. Star itself means any character any number of times. And this dot simply means the actual dot, and then md. So this will not match any substring. This will match anything and then ending with md. So I don't need to give dollar, and dollar will not work. So this itself means ending with md. So now you can see we get all those files that are .md. So now we have to not just list the name of those files, but also print the first 10 lines of those files. So there are multiple ways of doing this. We can do it directly using find also. Like in find, we have the exec flag to execute any arbitrary command on that each file. So I can do exec cat, sorry, not cat, head, because head will print the first 10 lines. So I can do exec head, and then this opening and closing curly brackets basically means put the name of the file here after head. And then we end the exec with a escaped semicolon. So here you can see we basically get the first 10 lines of this, which is 1 to 10. And then this is 100 to 109. Then again, like 1 to 10, then 10 to okay, so yeah, 1 to 10. Then we have 20 to 30, and then we have the 30 to 40, and then we have the 50 to 59. So all the first 10 lines of all the sequences that we created. Right, so this is one way of doing this. So here we just need one command to do the entire thing. There is another way to do this. So I can just get the name of each file, and I can then pipe this to xargs. So xargs is a command that basically builds command line for other commands. So it will read each line from the standard input, and it will build the command line. So here I want to run head with it. So if I simply give head and this, so this will like be even better. So each file's name is also printed along with the first 10 lines. So we can clearly see where one file ends and another file begins. So this is because if you are giving head multiple files, that is the default behavior of head. So if I give, let's say, what were the files? hjk, right? So if I give h.md and j.md, because head knows I'm giving multiple files, the default behavior is to like have a header for each file. And when we are running xargs, what xargs will do is it will not run head 5 times for all the 5 files. It will run head once and put all the files as arguments to head. So head will run with 5 arguments. So it prints all the 5 files directly. Right, so that is one of the solutions. So here you can see a few hints are given. So first thing is told that all the directories and files do not have space in their names. And then the hint is given that the type -f option searches only files in in find. So that is something we have used. And the name x* option searches for file name with pattern with wildcards. So this is not regex. So same thing that we discussed. So this is not regex but wildcard. So we have used the name with start.md to get all the files that end with md. And then finally we use xargs head to print the first 10 lines of each of those files. So the help page of xargs is also given here for you to refer, and also the help page of head is also given here. So you can see a few of the options. So the first option is find dot. So by default, dot is the default. So even if you don't give dot or if you give dot, output will be the same. So if you don't give a path, by default dot is taken. We're doing find dot, type file and name start.md. On that, we are running xargs -l1 head. So what is L1? So if we do man xargs, so you can see -l. So this is the max lines. Use at most max lines, non-blank input lines per command line. So what this will do is instead of giving all the files to head directly, where we get something like this. Right? So it will give one line at a time. So what this will do is, as you can see, the output is like this. So it is running head as many times as many lines are there in the standard input. So L1 means only take one line each for each execution of head. So it will only take the first line and run head. Then for the second line, it will run head again. And then for the third line, it will run head again. So this is running head as many times as the number of lines in the standard input. So let's say I make it head L2, then you can see two things are printed one by one. So because we are giving more than one file to head, head is giving the headers. But here what is happening is H and J are given together. So we are running, so basically xargs is running head h.md, j.md. So two arguments are given to head. So that's why we are also getting this header. And then again, it is reading the next two lines. So then xargs will again call head on i.md and l/file.md. And then again, it will run on m and k. So if I set L to be 1, head every time gets just one file as argument. and thus there is no header printed here. So that's why the first one is a valid solution. The second one, what we are doing is basically we are running the same command, so find.typef name star.md, and the output, which is basically lines of paths of file, that output we are giving as argument to head. So basically we are giving, instead of using xargs, we are directly giving those paths to head. So if we run it this way, we will again get those headers, right? Because this will evaluate to multiple lines, and when we are running it this way, it will become multiple words in the same command line. So head is getting all those arguments. So we can see that if we are using echo. So you can see this is basically the parameter list that is given to head. So this will basically run head and then h.md, j.md. So all the files are given as parameters to the head. So then head will print all of them in the order of the arguments, and it will also print the headers. So this is also a valid way of solving this question. And we have two other options. So here we have find dot type f name star.md xargs l1 head. So what is the difference between the third option and the first option? I don't see any difference in the third and the. Is there any diff? Okay, yeah, we have a star here, right? So this is star.md dot star. Sorry, no dot, star.md star. So what this means is there is a .md anywhere in the name of the file, whereas this means the file has to end with .md. So for example, if I if I let's say create n.md.txt. So if and let's say I put something here, hello. So if I am now running this thing, so this will not print that hello because we are not selecting that, because start.md means it ends with .md. But if I do start.md star, then it means a file whose name contains .md. So then you can see this end.md is also matched. So we are also getting this hello. So that's why this third option is not correct, because it will print any file which has .md in its name, whereas we should only print those files that end with .md. And yeah,
the use of xargs?
so xargs basically it will take the standard output, right? So standard input given to it, and it will build the command line for a command. So xargs by itself will not do anything. Here we are using xargs to run head, right? So I am using xargs to take the output of find and give each line one by one to the head command, right? So when we are let me go there. Yeah. So when we are just running this find, it simply gives you lines, right? So lines which has the paths of files. But I don't want the path of the file. I want to print the first 10 lines of the file. So that I can do by doing head h.md and then head j.md. But I don't want to do it manually. So what I want is take the standard output from this command and automatically run head on each of these lines. So basically, if you don't know xargs, what you will do is you will write a loop, right? So while read line, do head line, done, right? So then you get the same output basically. So first 10 line of each of the files given in the standard input. So you're reading each line one by one, and then you're giving that line, basically the name of that file, to head, right? So you're running head how many? 6 times. So you're running 6 heads. So the same thing, because it's very common thing to do, you don't actually need to write a while loop and all. You can directly use the xargs command. So if I do xargs l1 head, what this will do is it will run head with all the lines one by one. So it will run 6 head commands. Whereas if you, let's say, want to run head once with all the lines directly, like as arguments, right? So line 1 and then line 2, then line 3, then line 4, then line 5, then line 6. All the files you want to give directly in one head command. So that you can do without the minus L1. So then, because head is getting multiple files, it will also pretty print it with the headers this way. So the job of xargs is simply taking the standard in and putting it as arguments of the command given to it. Same as doing a while loop.
Okay, got it.
Okay, so the first two are correct, third is incorrect, and in the fourth one, we are doing find dot type f grep md head. So why will this not work? What are the things wrong in this?
Because if it is any file with the name MD will also be taken.
Yeah, so if the MD is anywhere in the file name, it will always match it, not just at the end. And not just that, so let's say I do this, right? So I do just find type F, so I get all this. And if I do grep MD, so obviously we are getting this .md.txt. So let's say we fix this by putting the end of line also. So now we are only getting the correct one. So will this work if I pipe it to head? That is how this is done, right? In the fourth option. So this will still
No,
not
it
work.
won't work. It won't work because it should be start dot MD.
No, okay, so that is fine. So if I put, let's say, dot also here. So if I do dot MD end of line, so this will, sorry, so this will give you the correct list of files. But if I pipe it to head, what will be the output?
The
If you pipe
five
it enter, it will be the
lines
first,
of
the first line. First line will be the
output.
printer. First of,
No, no, no. It will not
it
run
will
on
not
that
print the
file.
content of the file. It will print the file names.
Yes, exactly. So the
It
if we
will
have, let's
not
say,
read the content of these files,
yes, yes, it will
but
read the
only the
contents of
name.
the standard input itself. So here we have 6 files. Let's say we had 20 files. What this will do is just print the first 10 of those 20 files. So it will just print the path of those files. So it will just print that. So if I want to actually give this file name as an argument, then we have to use the xargs. So two things wrong in this question. First is the xargs is missing, and second is the dot and the dollar is missing here.
So the other thing we can do is, right, instead of the pipe, we can do minus exec exec and then do the file name.
Yes, 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 we can do that. So minus exec and then head and then this and this. So this, sorry, no. So this will not work because we are using grep. So it will work when we are doing directly in find. Right? So here, if I give the name to be dot md, and then
Oh,
it will
so if we do something like grep, it won't work, right? Okay.
no, no, because exec is a flag of find, right? So we can
Okay,
only
exactly.
use it with find.
That's fine. Okay.
Yeah. So this is also one of the correct solutions, although it's not the option, so we cannot select this. But just for completeness, we are also like going over this. So this is also one way of solving this. So let's move on. So this is one of like a script that we have seen earlier. So here we have associative array month to number, where we have stored all the keys January, February, March, April till December, and the values are numbers from 1 to 12. So then we are reading one line from input, and we are iterating over all the keys of this dictionary, right? So when we put exclamation here, that means the keys of the dictionary. So we are iterating over all the keys, so Jan, Feb, March, etc. And then we are seeing if this line matches this regex, so then we continue, but I mean, we do these next lines. But if this line does not matches this regex, so that's what will the or will do. So then we continue. So we basically go into the next iteration. So we don't do the next line. So only when there is a month in that line, then we go into the next line. So the next line simply prints that line and passes it into sed. And in sed, we are substituting that month with the value of that month in that dictionary. So we will simply substitute Jan with 1, Feb with 2, etc. Right. So here you can see there is no G. So if we have in one line we have 2 months like Jan and Feb, this will not substitute both of them. It will only substitute it once. Right. So it will print it 2 times, but it will not do it in the same line itself. And similarly, we don't have here I as well. So it is also not case insensitive. So only if the month is in like the first letter capital in this format, only then the substitution will be successful. So this is the script that is given. And then we have the question, choose the corner cases from stdin that makes this sed command fail to replace all the 3-character month names with the corresponding numbers. Right, so we have a few examples. So the first one is fine, so this will work because here we have JAN and it will simply substitute that with 1. Similarly, in this one also, AUG will be substituted with 8. So in the third case, we have 2 months present here. So what will happen is this will print 2 lines. So the first line will be 17/2/1888, comma 7/May/1999. And the next line will be 17/Feb/1888, comma 7/5/1999. So it will do substitution on both the months one by one on 2 different lines. So that's why this is not a correct line that will work. So that's why this is the correct option. So we are asked which will make this sed fail. So this will make the sed command fail. And similarly, in this option, we have lowercase. So because we don't have I here, so this joule will go unsubstituted. So this will remain as it is. So that's why this option is also incorrect. And the last one, again, we have a correct month, only 1 month, and correct capitalization. So this will also be substituted. And so hopefully this one is clear why these two are the odd one out in this. So here this is lowercase and here we have multiple months. Okay, so let's go to the next question. So here we have awk script. So complete the script to print the name in order of the given name and family name from the file name_country.csv. In some countries, people keep their family name as their first name and their given name as their last name. So note name_country.csv is a comma separated file with first name, last name, and country as field values. So the first field is first name, second field is last name, and country is the third field. So the file family name first countries has country names where the family name is used as the first name. Right, so usually we will have the first name as the given name, so what name your parents gave you, and this last name to be either like your like family's last name, or in some cases your father's first name. So either way, the last name will be basically the name that you inherit, and the first name will be the name that is given to you. But in some countries, it is the opposite. So the first name is the inherited name and the last name is the given name. So we are giving 2 files, one file that only has the list of the countries where this is the case, and one CSV file that has all the first name, last name, and the country given as a CSV. So what we are doing is we have a awk script and we have set the field separator to be comma. And then we are checking if the file name is family name first countries, right? So you can see in the awk script, we are giving both the files. So we are giving the family name first countries txt and the name countries csv. So it is imperative that we have to give this file first and only then we have to give the csv. If we give it in the other order, then this will not work. So what we are doing is, if the file name is family name first countries, then we are simply storing those basically country names, so $0 in a dictionary. So we have family name first countries dictionary, and we are simply incrementing the count. So assuming this will only have each country once, so the count will simply be 1. But basically this dictionary will then contain the name of all those countries which have this way of naming their children. So then once we have this dictionary of keys, which are the countries which have this inverted naming, then we have to basically iterate over the name_country CSV, and we have to print it in the order. So we have to print it in the order of given name and then family name. So if the country in which we are in is not part of this dictionary, we simply print $1, $2. But if the $3 is inside this dictionary, then we print $2, $1. Right. So hopefully till here it is clear. Right. So if the $3, which is the country, is one of the countries which is the exception, then we print in the reverse order. So we print $2, then we print $1. If not, then we print normally, so $1 and then $2. So let us see how we can solve this. So the first option is, if the file name is the CSV and $3 in the dictionary, right? So if the country name is one of those countries where it is printed in the reverse order, so then we check if $3 in, so we are checking it again, and then we are printing $2, $1, else we are printing $1, $2. So why will this not work? What is wrong in this? Any idea? So this logic part is correct. So if country is in that dictionary, we print $2, $1, else we print $1, $2. But why will this not work, or why will this not print all the lines? Anyone?
It is saying comma separated.
Yeah, so we've put the fs equals comma in the first part. That is fine. But the issue is, okay, so I'll tell that. So the issue is we are already checking $3 in like this dictionary in here itself. So this block is only executed if this condition is true. So inside this block, always the if will be true and the else will never be true. So we only print the name of those people who are in the countries which has the inverted naming. So we will not print the other part at all. So that's why this is incorrect. So basically everything else is correct here. We just don't need the and the second operator part here. So we just need file name equals country name, and then we need to use this if condition inside. So that's why this first option is incorrect. So this second option, which is the same but without this part, this is correct. So for all the lines of that country name.csv, if the country is one of those countries which have family name first, then we print $2, $1, else we print $1, $2. Right? Hopefully this is clear why this is working. So does it have any other options? Okay, we have another option which is correct. So here basically instead of using if condition, right, if else, we are just having two blocks itself. So we are checking if file name is country and $3 in the dictionary, then we print $2, $1, and then again we are checking if file name is this and this is not true. So $3 not in the dictionary, then print $1, $2. So this is also a logical way of doing this. So instead of getting inside the block and then using if to check, we can directly do the checking outside the block condition itself. So this is another way of solving this. And here the condition is inverted, so the option 4 is incorrect. So if the country is a country where family name is first, then we should print it in $2, $1, and not this. So this fourth option is incorrect. And so hopefully this one is clear how this works. So the heavy lifting part is already done by the script itself. So it has told you how to first of all match the file names and then how to store it in dictionary. So you already are getting a pre-initialized dictionary. So in the options, you just have to select the correct code which just checks the dictionary membership, right? So same as Python. So you're checking if this country is in this dictionary, then print this way, otherwise print this way. Right, so let's move on to the next one. Okay, so this is one of the questions that we have seen in the previous paper. So we basically have to print the dates in the order 4th April, 14th April, 24th April, and then after April we have basically May. So 4th May, 14th May, 24th May. Then we have June, so 4th June, 14th June, 24th June. And this will happen from 2004 till 2010. So we have to print it in the correct order. So the output of the command need not produce dates in temporal order. Okay, so here we don't have to print. Okay, so hint, use the following information. So we are given a few examples. So if we have two brace expansions together without any space between them, then we get a combination of those. So 1 dot dot 4 and b dot dot d will not give you 1 2 3 4 and then bcd. It will give you a combination of these. So it will give you all the combination of one element from this and one element from this. So 1b, 1c, 1d, 2b, 2c, 2d, 3b, 3c, 3d, 4b, 4c, 4d. Right. And similarly, we can also have any separator between them. So if we put, let's say, in a comma, semicolon, so we have semicolon between them. And if we have something with a space between them, we can use the tr space and new line to make it separate lines. And another example given here is how the date works. So if you give date minus d and then any date, and then you tell it which format to print that date in, so it will print that date in that format. So 04/21/2002. So this is 21st April. So this is the MMDDYY format, which is the default. And we are printing it in this. So name of month, date, and year. So we are printing it in this way, April 21, 2002. Right, so let us see the options. So we have 4 options. So what we are doing is we are doing echo 4.6. So we are not printing the name of the month correctly. We are simply giving the number. So 4.6 is April, May, and June. So 4 is April, 6 is June, 5 is May. Slash 4, 14, 24. So these are the dates: 4th April, 14th April, 24th April. And then we have the years. So 2002 to 2000. Okay, yeah. So this is not till 10. This is from 2002 to 2005. Right. So we are so only on 2002 and 2005. Wait one second. Okay, a file contains date is collected. The text, however, does not contain the date information. Now I just needed to add a column to this. Identify which of the following commands will create a column. Okay, so I think the year is not mentioned in this properly. Okay, but this one does for 2002 and 2005. And so what this will do is this will produce all the combinations side by side. So if we run this, if I do echo 4.6 and then slash, so just 4.6 will print 456. But if I give a slash and then we give 4 comma 14 comma 24, so these are the 3 options. So we will get 4/4, 4/14, 4/24, then 5/4, 5/14, 5/24, and 6/4, 6/14, 6/24. So we're still not done. So then we add the year. So it is 2002 and 2005. So then you basically get all the combination. So now you can see these are space separated, but we want them in new lines. So what we have done is we have substituted the space with a new line. So we can use the tr command to substitute the space with a new line. So now we get all the dates on separate lines. So then we have simply used the date command as shown in the example, and we have given each date to the date command, and we have printed the date in the format that is required. So here again we are using the xargs command, right? So the xargs is very powerful in that case. So usually in xargs, if you like mention a command, it will run that command and put the arguments at the end of that. But in some cases, you may need to put the argument in some other position. So in that case, what you can do is you can give a hyphen capital I and a symbol that is the placeholder. So usually we use the opening and closing brace, similar to the symbol for find. And this will be the placeholder where the line will be put. So then we can see we are running the date command, and we are mentioning the date with the minus d. So as you can see in this example, if we give any date and then we mention the format, that date will be printed in that format. So that is what we are doing. We are running date minus d, and then we are giving the date. So each of these date one by one will be given 2 dates. So date will be run as many times as there are lines in the standard in. And the format given is this one. So %d space %b comma %y. So the date, then the month in letters, and then the year. So if you run this, then you can see the order of these is same, but now instead of having them in this numeric format, we have them in the correct format as expected. So this is why this is the correct solution. So in this, it is told that we don't need the dates to be in any particular order. So although here the order is incorrect, as you can see, but that is fine because we don't need the dates to be in a correct order. So this is like 2002, 2005, 2002, 2005. but that is fine because we just need the dates and not in any correct order.
Excuse me, sir.
Yeah.
But this option should not be correct, right? Because in question it is asking from 2002 to 2005. But in the output we are getting only of years 2002 and 2005.
No, it is not. So the year is not mentioned at all, right? That is the confusion.
Yeah.
It does not tell from 2002 to 2005. The problem is it does not mention anything about the year at all. So like it is not mentioned anything. So in the previous paper where we were doing something separate, like we were sorting the dates and all. So there the range was told. But
In third para, it is writing 4th April 2004 to 24th June 2005.
desired. Okay. Yeah. So here it is 2004 to 2005, right? So this one is not correct, but the like everything else is correct, but this should be 2004 instead of 2002. So instead of 2, this should be 4. Then this will be the correct option. So I think that is also one of the options given. Yeah. So okay, here we actually are not using the date this way, but we are using the letter date directly, and then we are passing it to xargs. So let us see if this will work. So basically, there is some issue in this question, obviously, because they are asking.
In third option also there is dot dot not comma. So won't it print all the numbers between 2004 to 2005?
That is fine, right? Because between those, there is no other number. So these are consecutive numbers. So you will get only 2004 and 2005. So that is fine. Let us see if this numeric thing works. So here we have echo e, and then 4.6, and then slash. Oh, sorry, not this one. So we have echo e 4.6, and then space inside quotation. So we need this space inside quotation. We cannot directly give space because otherwise it will expand each thing separately and not as combinations. So then we give the month names and then a comma in quotation and then 2004 to 2005. And then we have a new line after each, right? So it is directly put after this. So we don't need to do the tr space new line anymore. This will directly put a new line after each. Although why are we getting a indentation here? Oh, okay, yeah, because echo by default will separate each thing with a space. And then we have directly the xargs. So after this, we are just directly giving it to xargs. So then we are telling that the date given is this, but it should be printed in the format which is percent. Okay, so format also is incorrect in this, right? So the order of the format is also incorrect. So okay, so here you can see this basically this way of giving the date is not accepted by the date command. So when we are giving the date to the date command using the -d, then we have to give it in the numeric way. So this first option is correct if this is 2004. So everything else in this is correct. But in the third option, the year is correct, but then the way of giving it is incorrect. So the June, July, August will not work for the date command. So in the fourth option, we basically have, so instead of doing 4, 14, 24, what we have done is 4 dot dot 24 dot dot 10. So what this means is we'll start from 4, we'll end at 24, and we will take a step of 10. So this will also do the same thing. So this will also evaluate to 4, 14, and 24. And here also you can see the year is incorrect. So it is telling 2002 and 2005, but everything else is same. So the format is also correct and everything else is same. So here the correct options should basically have a 2004 here in the first and the last option. And the third option is incorrect because this format is not accepted. Also, the format of the date is different, right? So we are asked to print it in a date month year. So which is there only in option 4 and option 1. So So in option 2 and 3, we have month, date, year. So that's why this is also incorrect, and you cannot also give like the named month to date. And in option 2, we have everything else seems correct, but the format is incorrect, right? So option 2 and option 3 are incorrect. 1 and 4 will be correct if this is 2004, right, instead of 2002. Yes, I think that is a mistake in the question. Right, but hopefully this is clear how we are getting the output, like how we are expanding and then we are changing the format using the date command and xargs.
Yeah, that's clear.
Okay, so let's move forward. Okay, so in this question, we are given directory equals $1, tarball name equals $2, and tar cvf tarball name dot tar directory. We are simply creating a tar from the given directory, and the name of the tar is tarball name dot tar. So here the question is, what will be the output tar file name if no input null string is given as the second argument? Assume the first argument of input is valid. So the first argument was the directory. So assuming the directory is given correctly, but the second argument is empty, right? So if it is empty, then tarball name variable will be empty. So what will be the this string? It will be only dot tar, right? Because this will be empty. So the name of the tarball will then be dot tar. So we will create a tarball with name dot tar on the directory that is given. So here the question is, what will be the name of the tarball, and ensure no space before and after the answer. So this you have to type using your keyboard. So here you can see the answer is dot tar. So this is a very simple question. So given this variable is empty, what will be the output of this? So this will simply become like this will be empty. So dot tar. So a tar of the name dot tar will be created. So hopefully this one is clear. So let's move to the next one. Okay, so this one we saw in the previous paper. So what we are doing is we have a function which iterates over a few numbers. So the numbers is different in this paper. So the numbers are 1, 2, 3, 4, 3, 2, 1. And for each number, first we are sleeping for half a second, and then we are printing that number without any new line at the end. Right? So it will simply print 1, and then after half a second, it will print 2 beside the 1. So let us also see that. If I have, let's say, f, or let me just give it same name, trn num. So here what we are doing is we are doing for c in 1, 2, 3, 4, 3, 2, 1, do, and we are doing, first we are doing sleep 0.5 or half a second, and then we are doing echo minus n. So this minus n means don't put a new line after each echo, and we are simply printing that number, and then we are done, and then we end the function. If I now run this function, you can see we get 1, 2, 3, 4, 3, 2, 1, and they have half a second delay between each number being printed. So then we have two running of this. So first is we are running a for loop 3 times, and we are simply executing this. So we are basically doing for I in 1.3. So this will run a loop 3 times, and there we are doing a prn num, and we're just running it in the foreground. So if we're running a command in the foreground, the for loop will wait for this to finish and only then go into the next iteration. So this will simply print this thing 3 times. So the output will be 1, 2, 3, 4, 3, 2, 1. Then again 1, 2, 3, 4, 3, 2, 1. And then again 1, 2, 3, 4, 3, 2, 1. So it will be printed one after the other. Whereas in the second part, what we have done is we have done for underscore in 1.3 do prn num ampersand. So what does the ampersand mean? It means it will be put in the background. Right? So when a process is run, like when the process is started in the background, so what happens is it will not wait for that process to finish. So it will simply run it in the background and then move on. So it will again run prn num in the background, and again it will run. So it will run the prn num 3 times, one after the other. So it will not wait for the thing to finish. What will happen is there will be 3 instances of prn num running almost simultaneously, and each will enter their own for loop, and each will wait half a second. Then all of them will print 1. So we will get 1, 1, 1. Then all of them will again wait for half a second. Then all of them will print 2. So we will get 2, 2, 2. So we will get each digit printed 3 times. So if we run this, you can see 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 3, 3, 3, 2, 2, 2, 1, 1, 1. Right. So instead of coming one after the other, they are interleaved. And another thing is that because they're running parallelly, so the total time taken was not basically 7 times 3. So it was not 21 by 2, which is 11 around. Like it was not 10 seconds, which the script took to take. The script took around 4 seconds, 3.5 seconds. So because each function was running parallelly, so they are not depending on each other. So this one loop inside this will run for 7 times, and each time it's sleeping for half a second. So this total thing will take 3.5 seconds. So they are running parallelly. So each of them are running parallelly and taking 3.5 seconds. So the total thing also took only 3.5 seconds, whereas this one took around 10 seconds.
So underscore stands for parallel.
No, underscore is just the name of the variable. We can give any name here. So I can give I also. So that does not matter. So this ampersand means this is running in parallel.
Okay.
So whenever we are giving ampersand after a script or a command, that will be running in the background. So if it's running in the background, then the shell is not blocked. So if it's then running something else, so that will also run in the parallel. So here we are running the same script 3 times parallel. So we get the output this way.
So what is the benefit of using ampersand like this in which of the situations?
So if you are running a few commands which are not dependent on each other, so you don't need the first script or the first command to finish for the second command to run. So in that case, you can run them this way, right? So you start them parallelly and you save time basically. So they're running parallelly. So if one command takes 10 seconds, another command takes 7 seconds. So your entire thing will be done in 10 seconds. Whereas if you're running them sequentially, it will take 17 seconds. Right? So you can save time by parallelizing things that do not depend on each other.
So here the above loop that does not have ampersand will take 17 seconds, but then the other one takes lesser seconds. So this is the optimized way to run heavy jobs, or in which of the business scenarios we typically use this kind of ampersand symbol, sir?
Yeah, so whenever you're running multiple things that don't depend on each other, you can parallelize them this way. So in this case, you can see that we are getting output also. So here the question comes, what is the order of the output? So if it's running sequentially, we get the output sequentially. I think it's not showing anymore. 1 second. So if I run it without the ampersand, then it will come sequentially. So we will get 1, 2, 3, 4, 3, 2, 1, and then again we will get 1, 2, 3, 4, 3, 2, 1. So also observe it is taking more time. Whereas if we run them parallelly, so 2 things happen. First of all, it will take less time, and second of all, it is coming in chunk by chunk, right? So all of them, because they're running parallelly, all the 1s are printed together, then all the 2s are printed together. So the output is also different. So in this, I think there are 2 questions. So the first question is, what is the output of the first loop? So we just saw the output of the first loop is this
I had a
thing.
follow-up question to the
3.
previous one. I had a follow-up question. If we
Yeah.
actually get rid of that sleep 0.5 seconds, would it still be interleaved in the same fashion, or the order will be maybe slightly random?
Yeah, in that case, the order may change. So let me remove this. Okay, so if I find this and then if I run this, you can see it is almost instantaneous. So if I now, so if I have this sequentially, then it will be same only 1, 2, 3, 4, and this way, one after the other. But if we have it in the background, okay, the output is even not clear because we also have the output of the jobs itself. Okay, 1 second. So maybe if I clear after this. Okay, so the output is something like this: 1, 2, 3, 4, 3, 2, 1, and then 1, 2, 3, 4, 3, 2, 1, and okay, yeah. So it is basically not interleaved, right? Because basically this thing is so fast, so that it's like the first one is finishing before even the next iteration is able to start. Right, so that's why to ensure there is interleaving, the function definition has the sleep there. So we have like half a second sleep here. Yeah, that was a nice question. So now you can see it will be very clear that it will always be interleaved. But if like the task itself is so fast that it can finish before the for loop itself can go into the next iteration, then instead of having interleaved, it can still be sequential. Or it may be sometimes sequential, sometimes interleaved. So hopefully this one is clear how we are getting sequential if we don't have ampersand. And the second question is what will be the output of the second loop. So in the second loop we have ampersand, so we are parallelizing them, and we have a wait, so we are getting them in chunks. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 3, 3, 2, 2, 1, 1. So that's how we are getting the output of the first and the second loop. Right. Yeah. So that is the end of this paper. So just let me know if there is any doubts and any question in this paper which we went through today. So hopefully all the questions were clear. Yeah. Okay. So this was the May forenoon paper. So I'll try to find the May afternoon paper. So I'm not sure if the PDF is mistakenly given as the January paper or the PDF is exactly the same. So either way, we will complete that in the tomorrow's mentor session, and I'll upload the recording for that also. So let me stop recording now.